Good day, friends. Welcome to my channel lecture series on power electronics. In this lecture, we are going to see the classification of DC machines. The DC machines are classified based on the field excitation as separately excited and self-excited. We know that a DC machine has got two major parts, the armature and the field. The way the field is connected with the armature besides the classification, and this classification is true for a DC motor or a generator. By machine, we mean either a motor or generator. So DC machines are classified based on the field excitation like this. If it is a separately excited DC machine, we have the armature and the field supplied by two different sources. And in the case of self-excited DC machine, the armature and the field are supplied from a same source. Based on the classification, the self-excited DC machines are classified as shunt machines, series machines, and compound machines. And compound machines are further classified as cumulative compound and differential compound. So if you see a separately excited DC machine, the armature is fed from a separate supply. The field is given a separate supply. The field winding is supplied from a separate power source. That means the field winding is electrically separated from the armature circuit. Separately excited DC generators are not commonly used because they are relatively expensive due to the requirement of an additional power source or circuitry. Self-excited DC machines are very widely used because they are fed from the same source. So it is classified further as series wound, shunt wound, and compound wound. In the case of a self-excited DC machine series wound, the field winding is connected in series with the armature winding. Therefore, the field winding carries the whole current. That is the load current. Whatever load is connected to the machine, the load current is going to flow through the series winding, and the current in the series winding as well as the armature both are same. That is why the DC series winding is designed with few turns. It's not many number of turns, few turns with thick wire, and the resistance is kept as very low, about 0.5 ohms. In the case of shunt machine, the field winding is connected in parallel with the armature winding like this. And here the full voltage is applied across the field winding. Shunt winding is made with a larger number of turns with a thin wire, and the resistance is kept as very high. It takes only a small current which is less than 5% of the rated armature current. In the case of a compound machine, there are two windings, and one is connected in series and the other is connected in parallel with the armature winding. Compound machines are further divided as long shunt and short shunt. In the case of a long shunt, the field winding is connected in parallel with a series combination of the series field winding and the armature winding. In the case of short shunt, the field winding is connected in parallel only with the armature winding. So the classification widely is like this, and here we see this. That is, in this lecture we have seen about the classification of DC machines, separately excited and self-excited, where in the separately excited the field winding is fed from a different source, armature is fed from a different source. In the self-excited case, series, shunt, compound, all are fed from the same source, but the connection of the field winding alone is different. So if in the case of a compound winding, if the field winding is aiding the flux in the flux in both the windings are aiding each other, then it is called as a cumulative compound. And if they are opposing each other, then it is called as differential compound. Differential compound is not widely used, but cumulative compound long shunt motors are very widely used. Thank you.